There are some general principles for choosing appropriate probability distributions for uncertain inputs in an at-risk simulation. For example, you can sometimes narrow the choice by assessments such as 1. The quantity must be between 0 and 100, 2. The quantity can have only a few discrete values, or 3. The distribution of the quantity is skewed to the right. Another approach is to fit possible distributions to historical data on the quantity of interest. Of course, historical data are not always available, but when they are, at-risk distribution fitting tools can be used. These tools automatically rank candidate distributions on their goodness of fit to the data, and then you can make the ultimate choice of the distributions you want to use. As an example, the data set you see here contains 3 years of weekly demands, 156 observations for a company's product. If a simulation model requires demands in 1 or more future weeks, it is natural to use a probability distribution that fits the historical data well. To find good fits, click the Distribution Fitting drop-down on the At-Risk ribbon and select Fit. Actually, if you already have fit a distribution to the data, it is shown at the bottom of the Distribution Fitting drop-down list, and you can choose it directly. Now, given this resulting dialog box, select the data range and the type of data. The data range should not include the top row that has the variable name. And I'll make this continuous data as opposed to the other possibilities. Next, click the Distributions to Fit tab and select the candidate distributions you want to try. Specifically, once you make some choices about the data in the left side, such as a lower bound of 0, and you're not sure about the upper bound, At-Risk checks all the continuous distributions that satisfy these conditions. If you have never heard of some of these distributions, you can uncheck them, as I will do here. Then you can click Fit. At-Risk fits each of the checked distributions to the data, it ranks them on goodness of fit, and it shows you the results graphically and numerically, as you see here. For these data, the best fits are the gamma, the Weibull, and the log normal, 3 very popular right-skewed distributions of positive quantities. You can see these fits in the graph, where the red curve is the gamma distribution, the green curve is the Weibull, and the purple curve is the log normal. The blue bars represent the histogram of the data. Actually, you can check any of these distributions on the left to see how well they fit the data in the graph. For these data, the triangular and exponential fits are not nearly as good. At-Risk actually ranks the distributions on 5 criteria, the first 2 of which, AIC and BIC, are new to At-Risk 6.0 and are preferred. The other 3 are chi-squared, Anderson-Darling, and Kolmogorov-Smirnov. The rankings can be slightly different depending on the criterion used. For this data set, the gamma, Weibull, and log normal distributions are the top 3 on all of the criteria. At this point, you could enter any of the formulas you see up here into a cell in the worksheet as the demand for some future week. Even easier, you can click the Write to Cell button to enter either of these distributions in a cell of your choice. I will do it for the gamma. Because of the good fits, you can feel comfortable that you have chosen a reasonable probability distribution for demand. Actually, you get some new options, as you see here, in At-Risk 6.0 when you click the Write to Cell button. Specifically, if you select Linked updates each new simulation option, At-Risk checks whether the data have changed when you run a simulation. If so, it refits the specific distribution with the new data. For example, if you choose the gamma distribution, it will find updated parameters of the gamma distribution when you start a simulation. In contrast, If you select the Live Updates Whenever Data Changes option, at-risk immediately refits and returns the best distribution whenever the data change. It accomplishes this with the new Risk Fit Distribution function shown here in the dialog box. I'll try this one. Here is the Risk Fit Distribution, and the corresponding cell comment reminds you of the gamma parameters. For example, the alpha parameter is 2.5657. If I now change some data, the parameters will change. As you can see, it's 2.7049 for alpha now. Also, with this cell selected, you can review the fit from the distribution fitting dropdown. There it is. Another change in At-Risk 6.0 is the addition of the Bootstrap option. If you choose this option when fitting a distribution to data, at-risk samples from the distributions being fitted to find distributions of their parameters, including confidence intervals for these parameters. I'll try it. By the way, notice there is the demand data that we already used. I'll just choose it. It remembers the settings. Then Bootstrap, I will run Bootstrap, 1,000 resamples with 95% confidence level. This takes a little bit of time. If you check this option, the next to last button below the fit graph is enabled. If you click it and select parameter confidence intervals, you get a graph like this one. This gives you 95% confidence that the alpha parameter for the gamma fit is between 2.203 and 3.427. There is one other important addition in At-Risk 6.0, the batch fit option. This can be used when you have multiple adjacent columns of related data, as you see here. In this case, batch fit allows you to fit distributions to all of the columns simultaneously. This not only saves time, in contrast to fitting them one at a time, but it also provides the option of estimating correlations between the data variables. The user interface for the batch fit is very similar to the interface for the fit tool, except that there is now a report tab. Again, I will not include the variable labels at the top. I can pick the distributions to fit, just like before. And in the Report tab, I can include correlations. I can place the report in a new workbook, or if I uncheck it, it will be in this workbook. And I can include a detailed report worksheet for each fit. The batch fit results include a fit summary worksheet with the best fitting distribution to each of the data variables: triang, log normal, Weibull, exponential, along with a matrix of estimated correlations. And further information about the fits for each variable appears in separate worksheets. Note that there are formulas in row 9 of the fit summary worksheet, like this one, including the risk format because of the correlations. You could copy these as part of a simulation model that requires values for these 4 variables.